There's also an effect of air pressure on our atmosphere and our weather. You ever wondered what causes wind? Why does the wind start blowing? Is there somebody with a giant fan somewhere that they turn it on and it blows and then it gets windy in Fresno? Where's it come from? It comes from different pressures. So why the pressures become different in different areas is beyond me right now. That's for the meteorologists. But they show you these maps, when they talk about the weather, and a low pressure system and a high pressure system. Well, air is going to flow from high pressure to low pressure, right? And you can also have localized changes and all sorts of effects. What meteorologists have observed is that high pressure is usually associated with clear weather and low pressure with unstable weather. So yesterday, the barometric pressure was lower than it was today, and it was rainy and weird, right? And now it's, just dropped a smidge, but it's 762, which is slightly above normal. So maybe we're in for some clear weather, which is it's what we have all the time anyway. It's boring. Anyway, just getting sidetracked. The number of gas particles in a given volume will decrease with increasing altitude. Think about driving up the mountain to Kings Canyon National Park. You're going up to like 7,000 feet in elevation, right? Up there, we say the air is thinner, right? It's lower concentration of air, which is also lower concentration of oxygen, which is why you're huffing and puffing when you're going on a hike. That and the fact that you don't exercise down here. The pressure decreases, right? You come back down, the pressure down here is back to normal. Pressure in mason jars. That's what those look like to me. So the pressure depends on how many particles there are in a particular volume. So here, these little red circles are the gas molecules, and this jar looks like it has about half as many particles as this jar does. If these are at the same temperature, the particles are all moving at the same speed, which jar is going to have more collisions? The high pressure jar, because there's more in here. Okay, so let's think about this. This is a kindergarten class, and this is another kindergarten class, right? Twice as many kids. This is crowded in here. Both of the teachers stepped out because they needed to talk to each other out in the hallway. So what are the kids doing? Running wild, right? Now, they have the same average speed. It's not like you have all the track stars in one kindergarten class and all the slow people in the other. They're like the same, right? So imagine kindergartners running around. Where are you going to have more collisions? People bumping into each other, running into the walls. Over here where there's more people, right? So a higher concentration of particles gives us more pressure. We can get pressure imbalances in our ears, and this is what we experience going up to like Grant Grove. So your ear has this eardrum here, which is gas and air proof and waterproof. So that's good because when you're swimming, it doesn't let water come into your head, right? That wouldn't be good. But your ear on this side of your eardrum is open to the atmosphere, and on the other side is open to your inner ear, which is not always open to the atmosphere. There is a little tube here called the Eustachian Tube, and that can open and release pressure, but it can also kind of get stuck, especially if you've got a cold, you're all congested. It doesn't work very well. So what happens is, as you go to an elevated altitude, you go see the big trees. You've got a reduced pressure on the outside of your eardrum, the pressure inside is the same as it was before you started this trip. So the pressure in here is greater. It's going to cause your eardrum to bulge out. Now, normally that just causes some minor discomfort, right? And how do you get rid of that feeling? You yawn or chew gum or just wait, and then you hear these popping sounds, right? That's the pressure equalizing through your Eustachian tubes. This is why babies cry on airplanes. The cabin is pressurized, but not the same as down where you were before. And so their poor little eardrums are bulging, and that hurts, and they scream because that's what babies do. When you come down, the opposite happens. Now, your inner ear was accustomed to the altitude, lower pressure. As you come back down, you've got greater pressure up here. Eardrum bulges the other way. And again, you have to get your ear to pop and equalize the pressure. Any questions? How do we measure pressure? This is an illustration of the Mercury Barometer, which is, I think, the first method of measuring atmospheric pressure. And the way this was created is they took a long glass tube, really long test tube basically, filled it with mercury, and then inverted it into a dish of liquid mercury. And you think, how did somebody think to do that, right? There were a lot of things that didn't work for all the things that did work. So the mercury is being pulled down, trying to come out of this tube because of gravity, but there's a vacuum up here, and nature doesn't like vacuums, so it's not just going to run out. The atmospheric pressure is pushing down on this pool of mercury. In order for this mercury to come out, the level out here has to go up. And so we're getting a balance between the pressure. The height of the column of mercury is going to be 29.92 inches at sea level. So that's a little less than a yard. That's a pretty big test tube. You ever play with cups in the bathtub and stick them in the water and get them all full and tip them upside down, and you pull them up out of the water, but you don't let it come all the way out, and the water stays in there? It's like, ooh, water defying gravity, right? It's neat. You know, kids are very curious, and they look at stuff like that. So you can make a barometer out of water instead of mercury, but this level here would be about 30 feet, which is a bit tall for most labs. It's like 3 stories tall. Mercury works better because it's much more dense, and so we get a shorter column. So pressure can actually be measured in how tall is a column of mercury, and it's literally measured with a ruler, 760 millimeters or 29.92 inches. So that's how millimeter of mercury, the length of an element, became a unit of pressure. If you have higher pressure, you've got a higher column. There's another unit called a torr, which is named after Torricelli, who is the guy who came up with this barometer. A torr is just a different name for millimeter of mercury. So they're interchangeable. There are a lot of other pressure units. When we convert pressure units, we can always do them in one step because of how the pressure units are presented to us. This is the table from your textbook. It shows pascals, pounds per square inch, also known as PSI. That's what you are looking at with your car tires or bike tires. Torr, or millimeters of mercury, inches of mercury, and atmospheres. So what's an atmosphere? Well, an atmosphere is the pressure of the atmosphere at sea level. It's 1 atmosphere, right? So 1 atmosphere, and then you can express that in all these other units. So 1 atmosphere is 29.92 inches of mercury, which is equal to 760 torr, or 14.7 psi, or 101,325 pascals. The only one that you should even attempt to memorize is that 760 torr, or millimeters of mercury, equals 1 atmosphere. But I'll give you pressure conversions if needed on an exam, but I'll give them this way. So I don't recommend, when you have a homework problem where you have to convert pressure, I don't recommend using Google, because Google just, uses all kinds of funny things. It'll probably give you the correct answer, but you're not going to learn how to do the problem, and Google can't take your test for you. So let's convert a pressure unit. Local weather report announces that the barometric pressure is 30.44 inches of mercury. Convert this pressure to PSI. This is dimensional analysis again. 30.44 inches of mercury, trying to find PSI. One step. You can always do this in one step. I mean, you can make it longer if you want to, but you just need one step. So we're going to go from 30.44 inches of mercury to PSI. One step, 30.44 inches of mercury. We've got one fraction, it's an H. PSI goes on the top, inches of mercury goes on the bottom. So those guys are going to cancel out. Then I go look at a table from your book, or a table, the one on the exam will look a lot like this. All of these things are equal to 1 atmosphere. So they are all equal to each other. So I can just pick the numbers I need. So 14.7 PSI is equal to 29.92 inches of mercury. So I get 30.44 times 14.7 divided by 29.92, 14.9554, and it keeps going. How many sig figs? 3. This conversion factor only has 3. I don't know why your book did that. It's 14.69. They know it to way more digits. There must have been a reason. This one's limiting it. If you're using torr or millimeters of mercury, that's an exact number, because exactly 1 atmosphere is defined as exactly 760 millimeters of mercury. So this should have 3 sig figs. And so we report the answer as 15.0 PSI. Any questions? A manometer can be used to measure the difference in pressure between a container that's closed and the outside. It uses the same basic idea as the barometer, where you have liquid mercury in a tube. If this side was open to the atmosphere, the mercury would be equal on both sides, right? It would just fall to the bottom of the tube and the levels would be equal. Why is it lower on this side? Because the pressure of this gas is pushing on it harder than the atmosphere is pushing on it over there. If this pressure was lower than the atmospheric pressure, then this side would be higher. So you can measure the pressure difference as the difference in height between the columns of mercury.